Alrighty, so I'm giving you some time to work on this. Let's go through and talk about it. This says, while driving down a dirt road, you puncture the tire of your truck. The table below shows the pressure Y measured in pounds per square inch. If the air in the tire at any given time X measured in seconds after the tire was punctured. Okay, so this is in terms of X and Y. We don't have anything else. It tells me to find an exponential function, so I'm not making any decisions. And this form, so we just put it straight into Desmos, do your regression. Remember, yours should be green at the top because I'm cheating up here. And your log mode should be the defaulted checked. You want it checked. So there it is. So there's your equation. Did anybody have any issues getting that? We can handle that, right? So we got y hat equals 33.87953 times 0.95513 to the x power. Okay, we're all good with that? All right. Then it says using the model, what was the pressure of the tire when it was punctured? Now, we write down the decimals, but we never type the decimals back in, right? You just let the computer do what it already has in there. Technically, you kind of could do this one by hand, if you want to call it that, without having to worry about the calculator again. But because when was it punctured? At 0 seconds. So it's at x equals 0. Well, if you think about it, when x is 0, this to the 0 power is going to be 1. So shouldn't my answer just be this 33 number? But if you're not sure, or maybe that doesn't even enter your mind at that point, which is fine. Over here, you could type in x equals 0, but because it is an intercept, you don't even have to type it in. It's just, it'll already be there for you that you can click on. And that might be when you recognize, oh, look, it's the exact same number. But that y hat there is 33.87953, okay? And then what are the units there? PSI, right? And somebody asked me if you had to have an equation there, and the answer is no. You don't have to show that you're substituting in X or anything like that when it is the when you're doing the calculator. You just let the calculator do it for you, or let the computer do it for you. Okay, we all good with all that? Then it tells us to plot the residuals, which is super easy to do on Desmos. Not so easy to do sometimes on the calculators, but there we go. I'm going to zoom in so that I can look at them. And then it says, what does this tell you about the validity of your regression function? All right, so what says explain what you see in the plot. All right, so what do we see? No, yeah, it's just random, no clear pattern, right? And so we can say something like, and your words may not be exactly like mine, and that is okay. Let me write some stuff down, and then if you have a question about whether or not yours is good or bad or whatever, we can talk about that. But so the first part says explain what you see in the plot. So I can say the residual plot shows no clear pattern. And then pattern. Therefore, the regression is valid, or is good, or is appropriate. I'm using the word valid because it said validity, but as long as you say something along those lines, as long as you have said that we don't have a pattern and you think it's good, that's good. Don't say it, though. The regression is valid, or the model is valid, not it is valid, because be very careful with it in there. Okay, any questions at all? We all good with all that? Beautiful. All right, so let's look at example 6. A set of data has an upward trend shown in the plot below. It is not clear whether the best fitting function is linear or exponential. Use the regression plots to determine which regression function would best model the data set. Okay, so just make sure, because these aren't necessarily difficult questions, but make sure you know what you're looking at graphically. This is the data plot. This is the data itself, which we could say maybe has a little bit of a curve to it, or maybe even it kind of could possibly be linear. That's probably not the best place to put it, but you know, maybe we're not sure, but that's why we look at the residuals. So then when you look at the residuals and we know that this is what we're looking at, these are not my data points, right? So I'm thinking about them differently. Which one looks like it should be a better fit? The exponential, because this has no clear pattern. This kind of has, it definitely has more of a pattern than that one does, right? And so it says to use the residual plots, blah, 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 and explain why. So here we could say clear pattern. And so that's bad. And then no clear pattern. And that's good. It's good enough. Okay. Questions? All right. Then a group of AP pre-calculus students used a set of data to create linear, quadratic, and exponential regression models. After creating the 3 models, the students created a residual plot for each type. So all 3 of these are residual plots. There's no data plots there. Based on the 3 residual plots above, which model was most appropriate for the data? Give a reason for your answer based on the residual plots above. All right, so this first one, if this was the data, we'd say, you know, it probably looks pretty quadratic, right? You're not even like, looks quadratic's probably the best, but that's not what this is. This is residuals. So since we see a pattern, do we like this one? No. Okay. So on this next one, I see a pretty defined wave there. So do we like this one? No. Really, on any of these, you could technically force some sort of pattern, because you could say, oh, well, look, this one zigzags like that. But I mean, that's kind of trying to push it, right? That's pretty random. Anything random, we could probably connect dots and make something out of. But of all 3, this one definitely is the most random, right? So we can just say that it is exponential is most appropriate okay, because residual plot, and make sure you're using residual and regression carefully. Like on the other one, we said regression, we're saying that it is valid. Here we're talking about the residual plot, so don't get the R words mixed up there. Because residual plot shows no clear pattern. Something to that effect. Okay. Everybody good so far? Any questions at all? All right, let's flip it over. All right, Mr. Passwater hopes to make it into the Guinness Book of World Records by painting the world's biggest mural on the sides of several downtown buildings. His mural will consist of many painted circles of various sizes, where each circle is painted a different color. If he wants to create a model to determine how much paint is needed in quarts for a circle of radius r in feet, should Mr. Passwater use linear, quadratic, or exponential model in this situation? What do you think? Quadratic because it's area. Exactly. If you're going to paint a circle, you're going to paint on the inside, you need to know the area of the circle so you know how much paint you need, right? And so that would, I would definitely say basically what he just said is quadratic, because he needs the area of the circle, something like that. Ugh. Can't even write correctly. Okay. Everybody get that? Okay. Then after creating his model, Mr. Passwater uses it to purchase different special paint colors to use on his mural. In this situation, do you think it is more appropriate for the model to underestimate or overestimate the actual amount of paint needed? What do we think? Overestimate. Why? Right. So he has enough paint to finish, right? And he could just have extra. Extra is better than having not enough. Okay. So we would say overestimate. So he has enough paint to finish, something like that. it sounds like, I mean, everything we've talked about, we're like, oh, well, we would need to overestimate. If you needed enough food for something or you wanted whatever. Anybody think of an example of when you might want it to underestimate? Yeah, me either. I have no idea. I was like, I really need to think about that. There's probably something pretty obvious, but like all the overestimations are the ones that come to mind for sure. All right, any questions? All right, good deal. So Mr. Breast started a new online business selling breast merch. He estimates about his revenue. He made estimates, sorry, about his revenue and used an exponential regression to develop the model over time. The figure above shows the graph of the residuals for graph. Oh my God. The figure above shows the graph of the residuals of the exponential regression. Oof. Which of the following statements about the exponential regression is true? Okay, so again, these are fairly simple, I hope for y'all. But make sure, especially because when we get some other plots in here, sometimes they get mixed up with residuals, that you know, if you pay attention to, are we talking about this being the data or this being the residual or this maybe being something else? It clearly says that this is the graph of the residuals. So this looks like a very nice quadratic. Does that mean anything for this? Well, it means that it's bad, right? The fact that it's a quadratic doesn't necessarily mean anything, but the fact that I have a pattern is bad, right? I don't want it to do that because it's not data, it's the residuals. So this says the exponential model is appropriate. Well, it's bad, so we know it's not, like I don't even have to read the rest, right? That's not true. The exponential model is appropriate. Again, I can stop reading, but this then goes on to say because there are data points both above and below the x-axis. That really has nothing to do with anything. And then the exponential model is not appropriate. These both say that. Okay, it says because there is a clear pattern in the graph. Pretty sure that's it, but we should read D because this also says not appropriate because the residuals are not in an exponential pattern. No, we don't want the residuals to be in any kind of pattern, so our answer is definitely C. Okay, everybody good with that? All righty. Okay, last one here. Students from an AP pre-calculus class were brought to the gym to shoot free throws, but only the students with little to no basketball experience were allowed to shoot. Each student was given 60 seconds to shoot as many free throws as possible. A regression model was calculated with the student's height in inches as input values and the number of shots made as the output values. The residual plot for the regression model and data points is below, okay? So it's not even telling me what kind of regression they did. They're just saying this is the residuals, which looks pretty random. So I'm thinking whatever they did, probably pretty good, right? So it says, given the residual plot, and again, this is residuals, has a point labeled P, here's point P, at the coordinate 62, 4.7. What does point P indicate in this context? So remember, when you were looking at a residual plot, whether it was exponential, quadratic, whatever the curve is that you had has been flattened out, and this is now your y hat, right? That is your new x-axis. And the x values still mean the same things. The input values are the same no matter what. So what does this 62 represent? Okay. Yes, but the 62 itself, the height, the 62 is the height, because if the input is the same no matter what, okay? Now that this does not mean that the 62-inch student made 4.7 free throws. That's not what that means, because this represents the residual, right? We don't know what the y value was because we flattened it out, just like here. Look at your, oops. So if I do this, okay, we can see the green points, right? Those are our actual y values, and then these are the residuals. The x values are the same, but the new y values here, those are the residual points themselves. So it is definitely an underestimation, but what does that 4.7 represent? It's how far off it was, right? Exactly. It's the residual. It's the actual minus the predicted. So it's how much it underestimated it. Does that make sense to you? This right here, this distance, this is 4.7. Okay. So what point P indicates in this context is that the model, because my next question was going to be, but it's already been answered, which is fine. This is my model. It is under that point. So the model underestimated the number of shots made Did it underestimate all of them? No. And this point, that ordered pair itself only tells me about the number of shots made by the 62-inch student. By 4.7 shots, which you can't have a part of a shot anyway, but when it's a model, you know, the numbers aren't going to come out beautifully. Okay, does that make sense to you? That's what that's actually representing there. Okay, so then we have this point Q. Now this model, did it overestimate or underestimate? Overestimate, because it's over it, right? And it's basically the same type of answer here, is that the model overestimated the number of shots made by the 74-inch students by 2.4 shots. And it's not a negative 2.4 shots. It's 2.4 shots. The negative is because it was an overestimation. Okay. Any questions about that? We all good? Beautiful.